Hey guys, this is Mr. Skeleton Man here, back with another crash course episode of all the basics you need for C Sharp. Last time we left off with this question on why 5 divided by 10 equals 0, and put it simply, it's because we are returning an int, which cannot be any kind of decimal value, whereas if we wanted to actually see 0.5, we would return a decimal. So for example, if we change all this stuff up to decimal. Oops. What happened? There we go. Oh, okay. There we go. 2, 3. We go to decimal. This is a wreck so far of an episode. There we go. Okay. Just don't worry about the names for now. You get the idea. So then, if we just return all those values, we should see either .0 or .5 or whatever kind of data we put in. So let's start that up. And we try the 5 divided by 10 again. We should get 0.5. What? Ah. How'd they get switched? Let's restart that one. There we go. 5 divided by 10. There we go. 0.5. Whew. Thought I was going crazy for a second. So that's just a really quick example of knowing what kind of data type you're using and what you're returning and what you are expecting to return. Because if you're returning an int, but you're doing some kind of division, multiplication, anything with decimals, you're just not going to get the values that you want. So let's move on to the next topic, which are going to be collections, another kind of data type. Another kind of data type for you to use. In this case, the more popular ones are going to be arrays, lists, and an Enumable, which is another list kind of thing. So this time, instead of walking you through it, I kind of went ahead and already started the code for this, just to kind of explain how these things work. So first, we're going to go over arrays, and these you can think of collections as like a box with boxes. Going back to the box metaphor, um, this array kind of holds a bunch of different values in it. In this case, with this example, ints, different ints in it. Um, then there's a few different ways you can implement an array. In this case, here's the first way where you just have an empty array, um, where array test just has nothing in it. It's basically just null. So if you were to try to enumerate over it, it would just throw you an exception. And then another way to implement it is array is the same, kind of the same start off as that, but then it equals a new array, but this time you're giving the array a size. So in this case, a size of 1, which means you can hold one integer in it. Next, you can do, going back to like the var declaration, and then the array2 equals new, and then int 1, just like the above, where you're giving it the size of 1. And lastly, if you want to create an array that has some values already in it, you can start with int, bracket bracket. You need those if you want to declare that the variable is an array. So we do int bracket bracket, whatever name you want, equals, and then squiggly brackets for whatever data you want to put in this case 1, 2, 3. And so the interesting thing with arrays, when you want to grab values from it, is that the index starts at 0 instead of 1. So in this case, we want to grab the first int in this list. So we go 0, 1, 2. And I can easily show you this real quick by starting this up. and go into the arrays endpoint, hitting execute, and we have 1, the first integer in our array. So that's a very simple way of seeing how arrays work. So next in the collections is the list itself. So it's very similar to an array where it's holding a bunch of the same data, in this case integers as well. But you can do a little bit more with it. There's different built-in methods that you can use. There's just a little bit more you can do with it in general. It's still very similar to an array though. Now the way to implement this is similar how you define list and then whatever data type this list is going to hold, and then whatever name you want. In this case, this will be an empty list of int, so there's nothing in it right now. Or we can go back to the variable declaration equals a new list of whatever type int. And in this case, you do not have to define the size of the list. You can just leave it. Doing it like this just leaves it empty. And then the other one where you want to create a list with variables or values in it, you can do the same thing, new list of type int, and then squiggly brackets, and then whatever data you want. And the list works the same way as the array, where the indexing is 0, 1, 2, 3. So this time we're going to grab the second value in the list when we go to activate the list endpoint. Boom. Number 2 is exactly what we expected. So that's pretty simple there as well. Next are enumerables. In this case, IEnumerable is going to be an interface rather than an actual data type. So an IEnumerable, you can implement either a list or an array and then declare it as an IEnumerable. What this does is when you do this, when all the values in this IEnumerable or IEnumerable list, they're going to be read-only once you declare it an IEnumerable. Like you can't manipulate whatever data is in that list anymore. So what you want to do is, if you're going to go this route, is you want to make sure the data you're putting into the IEnumerable, you're not going to want to change later on because you're not going to be able to. Whereas with a list or an array up above, you are able to go in and manipulate the data that's in it and change it however you want. But IEnumerable, you cannot. Once it's in, you can't do anything with it other than grab it. So in this case, let me update this. IEnumerable. So in this case, to implement it, you can do just IEnumerable, the data type of it, and then the variable name. Or you can do var variable name. And in this case, we're doing enumerable.empty and then type the data type. So what this does is, here, let me show you the difference. So in this first one, if we hover over the variable, we see that it is of type enumerable, that IEnumerable of int. Whereas the second one, if we hover, we see an IEnumerable of int, but it could be null because what we're doing, since it's empty, at this point there's nothing in it. There's nothing to access in this list. So that's why in this point it's just with a little question mark next to the int that says that it's possibly nullable. Could just be null or empty. So then we want to initialize it. Like I said earlier, you want to create a list and you can add whatever values you want in it. In this case, the same thing as 1, 2, 3, 4. And then you change it, and now you can't do anything with it. And to show you that, I will do list. Test list 3 dot. Let's do element at 0 equals 5. Oops, sorry. So quickly look, trying to manipulate the data that's in the IEnumerable. Here we're trying to grab the element at 0, which in this case would be 1, and we're trying to make it 5. And of course it's having an issue with that because you can't change the data that's in an IEnumerable. So let's get rid of that. Let's show you how this works. Oh, and to index through an IEnumerable, you need to use the element at function. You can't do the bracket whatever index you want. It doesn't work with IEnumerables. So let's continue. Let's try it out. We're grabbing the first element, which is, of course, 1. So, plain and simple. That's all you need for these collections. There's plenty of other different kinds of collections. And another popular one is tuples. They're very popular with Python. I know that. However, with C Sharp, I hardly ever use them, so I don't think there's much use in going over that right now. Maybe later, we'll see. So next, we're gonna go over another basic thing which you'll use constantly, and those are loops. So there are 3 different kinds of loops. Actually, there's more, but the 3 basic ones for C Sharp are the for each, the for, and the while loop. I think the for each is probably the most popular or most heavily used. But I'm going to go through each different collection that we've gone over and show you the different kinds of loops and how to use them. So this first one with the arrays, we're going to use a for loop, as you can tell. And the way to do this is you need to first declare some kind of variable that's going to keep track of the indexing. Next, you want to figure out what statement is going to finish the for loop. In this case, whenever whenever the value of I is equal to the length of this array, then that's when we'll stop. Otherwise, while I is less than the length of the array, we will keep going through the loop and do whatever we want to do in here. In this case, why don't we add up all of the values? So we're going to need a variable. Let's do the total. In this case, 0. So total equals, I want total plus array, yep, array test3 at the index of I. So what this is going to do, it's going to keep adding to the total at array test 0, array test 1, 2, 3. Well, 1, 2. Oops, what did I do? And of course, we're going to want to return this. And then, sorry, I don't think I went over this third one. So this third argument is you want to increase the value of your index, I in this case. And so I plus plus means that at the end of this, it'll add 1 to I. So first time we go through, I is going to be 0. And second time we go through, I is going to be 1, and then 2, and then it won't go through again because I will no longer be less than the length of the array. So we should see 1 plus 2 plus 3, which will be 6. So let's try it out. Oops, wrong one. Yep, there you go, 6. Hopefully that's pretty clear. One way to know when to use a for loop is if you know how long you want to loop. In this case, I know I want to loop the length of the array. Then that's when you want to use a for loop. I'll explain later on with the while loop, but when you want to use a while loop, that's when you don't know how long you want to loop. I'll explain later when we go over the while loop, but that's kind of a little bit of a difference there. Next, we're going to go over the for each, as defined by for each. In this case, it's a little bit easier. We want to define a variable, and then we're going through whatever collection we want to go through. In this case, list 3. So what this is saying is for each integer in the list, we want to do. Let's just do the same thing. Keep it simple. total equals 0, and we'll do total. I'm going to do a little bit different as another way to explain what's happening. We'll do list 3. Oops, sorry. Integer. Duh. My brain just stopped working for a second. So what this is saying is for each integer in the list, each time we loop, we're going to add the integer value to the total. And this plus equal sign, basically, it's the same exact thing as what's going on here. You're saying total equals total plus integer. That's all that's really saying. So in this case, this loop's going to go through 4 times since there's 4 different values, and we should see the value of 10. 10. There we go. Another simple one to go through. Next is going to be the while loop. As I mentioned earlier, the while loop you want to use when you're not really sure, how long you're going to be looping for. So in this case, with the while loop, you're going to want to have an integer defined before the loop, so that you can kind of keep track of your indexing. The same way we would with the for loop, where you had the int I equals 0. Here we're going to have integer equals 0 here. And to set it up, we have the while the integer is less than basically the length of the IEnumerable. With an IEnumerable, you use count instead of length. And that's just how it is with IEnumerables. Don't have a good explanation for that. And again, we're going to do the same thing. Var total equals 0. We're going to do total plus equals list 3 dot element at integer. And then since this is a while loop, we want to update the index in the while loop so that each time it's looping through, we're adding 1 to the index. And so in this case, we should also see 10 once I update this and try it out. And we have 10. Cool. I hope that makes sense. We can go through a little bit more later on and try it out more heavily. But next, we're going to go over exceptions and the try-catch statement. So what is an exception? An exception is basically when you did something wrong or something unexpected happened that you just didn't realize could even happen. Things like simply dividing a number by 0. That'll throw an exception. Or let's say you want to index out at element 5, even though there is no element 5 in this IEnumerable. That'll throw an exception. An exception it'll just blow up your program. Like it'll stop working entirely. And I can quickly show you here, list 3, element at, we said 5 should not work because there is no index at 5. So if we try it, we will see an index out of range exception. There are a ton of different kinds of, there we go, argument out of range exception. There are a ton of different kinds of exceptions. It can happen for a number of different reasons, either just, you're at the wrong index for whatever reason, you're trying to grab data or a value from a variable that is null. There's a bunch of different reasons for it. So you want to try to code as best you can to reduce having exceptions. Can't always happen, can't always prevent all the exceptions, just how it is. But there's an easy way to also catch these exceptions before they blow up your program. And that's what the try catch is for. Hence the name. So basically, based off the name, when you try something, there's a potential chance that there could be an exception thrown. And if there is, then you catch it, do something with it, and move on, kind of thing. Rather than an exception thrown, it breaks your program, and now your whole system's down. So let's try it out where, let's go back to the original one. Let's try and divide. So to start out with the try catch, you want to do try, and you need the squiggly brackets, of course. I'm going to put the switch statement inside the try catch because that's where the exception could be thrown. Then I want to do a catch where the exception is X. And we don't have to do anything with this, but well, I guess here we'll return 0 in this case. So when this is called, we're going to try to do some calculations. If an exception is thrown, then we're going to catch it and just return 0. I'm going to, just so we can see that it's not defaulting, I'm going to return 100 for default instead of 0. So we go to our calculator. We go, doesn't matter. We're going to divide by 0. And bam. See, it did not blow up, and we just returned 0. So it's a really simple way of catching any issues that could just destroy your system. But there's also a little bit more you can do with this. There is a finally statement that you can put at the end of your try catch. So what this is doing is it's going to try this. If we catch it, we can do whatever we want, but then we're still going to do this. Or another thing that could happen is you could go through this and not have an exception, and you'll still run through this code. I can't think of a good scenario off the top of my head right now. I will try and edit something in, possibly. I don't know. But let's say we're dividing by 0. So the most simplest example I can think of right now is let's just add 1 to the final value. I don't know. I can't think of any of a good example. So this is what I'm going with. Final result 0. So we're gonna do final result equals final result equals. Oops. There's a faster way to do this. Like that. We'll do a plus equals here. And final. Wait. Return. There you go. +1. There we go. Jeez. Whew. Oi. Oh. D. Nope, sorry. M. What's happening here? I fall through one case level to another. Why? Okay, so that example crashed and burned. So we're gonna try a different example here in the for loop. We're gonna try and catch. Same way as before. Putting the loop inside here. In this case, I'm gonna do an equals. This way, it's going to index out of the array, and it's going to cause an issue, which we don't want. Going to catch it. Get the exception there. Instead of returning 0, we're going to add to the total. This case, I guess total. Should we just do 1 again? Sure, keep it simple. But finally, this is where we are going to return total. Wait, what? Can I? Bruh. Better yet, going to total plus equals 1,000. There we go. We're gonna know that it's returning correctly. Holy crap! Stupid examples. So let me recap. We're gonna try to go through this for loop. However, it's gonna fail because when I equals the length of the array, that means it's going to equal 3. It's going to index at array index 3, which does not exist. Remember, 0, 1, 2, and there's no 3. So that's going to cause an issue. We're going to catch it. We're going to add 1 to the total just because I don't know what else to do in the catch. And we're going to finally, we're going to add 1,000 to the total because I don't know what else to freaking do. And then we're going to return the total. So here we go. It built. Oops, erase, try it out, bang. There we go. So there we can see that finally had worked. I think we would have added all of these because it would have been 6 plus the 1 plus 1,000. So yeah, 1,007 is correct from what I can tell with my mathematics skills. And that's gonna be it for this episode. Um, Next one, I'm planning on doing like an actual in-depth trying, questioning quiz for all of you for me to solve and show you how to use all these things all together a little bit more in depth because you can use objects with arrays. You can use, or not objects, or arrays. You can use objects and stuff in your collections. Um, There's even this thing, very popular thing called link, LINQ, that I'm going to go over very briefly. I'm going to do another video on that to go more in depth with that because it's such a powerful tool in C Sharp. Yeah, so there's going to be a lot in the next episode. Hope you enjoyed this one. Sorry for the train wreck of an episode, but hey, not everyone is good with coding. What can I say? Anyways, catch you later. Bye bye.